Assalamualaikum. My name is NASREEN AISYAH. Now I will discuss about introduction. What is first order differential equation? A first order differential equation is defined by an equation dy over dx equal to fxy of two variables x and y, with its function fx defined on a region in the xy plane. It has only the first derivative dy over dx, so that the equation is of the first order and no higher order derivative exists. What is the application of it in real life? Ordinary differential equation applications in real life are used to calculate the movement or flow of electricity, motion of an object, and to explain thermodynamics concepts. Also, in medical terms, they are used to check the growth of disease in graphical representation. In the application of first order differential equations, it has two types of applications, which is applications of separable and application of first order linear differential equation. Under the application of separable, it has growth and decay, radioactive decay, Newton's law of cooling or warming. Next, under the application of first order linear differential equations, it has mixture problem, electric circuit, RL and RC circuit. Okay, for our topic, we choose Newton's law of cooling. This is because Newton's law of cooling really an interesting topic and mostly used in our daily life. So, we can easily understand and see the example that applies in our daily life. For example, the rate of cooling of hot water in pipes, cooling down of hot beverages, forensic science, and many more. That's all from me. Now, for the problem statement, I will pass it to HAMIZA.
Thank you, Nasreen, for the introduction. Now, I will continue with problem statement. The problem statement that we choose to discuss is: a police officer received a report of corpse found in a motel at midnight, and the temperature of the corpse at the time was 80 degrees Fahrenheit. The temperature of the room is kept constant at 60 degrees Fahrenheit. 2 hours later, the temperature of the corpse dropped to 75 degrees Fahrenheit. So, we need to find the time of death. The solution for this problem statement will be discussed by Hannah.
Hello and good day. My name is NURUL and I will explain the solution for the problem statement discussed by HAMIZA. To start with, we will highlight the information given to solve this problem. A corpse was found dead at 80 Fahrenheit by 12 a.m. and the constant room temperature was at 60 Fahrenheit. After a couple of hours, the temperature of the corpse dropped to 75 Fahrenheit. By the information given, we will solve the problem by using Newton's law of cooling or warming equation. T minus null T equals to A multiplies exponential to the power of K T. Afterwards, we will make a table. Small capital letter T represent hour at the left hand side, and big capital letter T represents Fahrenheit at the right hand side. At 0 hour, the corpse was found at 80 Fahrenheit by a police officer, which is at 12 a.m. Then at 2 hours, the corpse temperature dropped to 75 Fahrenheit at 2 a.m. Thus, the question is, at what time the corpse is dead at a normal body temperature of 98.6 Fahrenheit. Firstly, we need to find A and K respectively by substituting the information given into the equation. After we got A and K, we can see that the value of K is in negative sign that specifies that the body of the corpse loses its heat. Secondly, we will need to find G, which is in hours, by substituting the value of A and K that we got and insert into the equation. Hence, we will get negative 4.57 hours. We must also not forget to convert 0.57 hours to minutes by multiplying 60. Then we will get 34 minutes. As a result, we have found that the corpse time of death is at 7:26 p.m., 4 hours and 34 minutes before midnight. Next, I will pass to NURHAZEEQAH for our conclusion.
Okay, thank you Hannah for the explanation about the solution. So I will continue with the conclusion for this video. From the solution, we can know the time of death is at 7:26 p.m., which is 4 hours and 34 minutes before the corpse is found. In Newton's cooling law, there are some limitations in it, such as the radiation should be the only sources of heat loss from the body. Second, small temperature difference between the body and its surrounding. Third, the surrounding temperature must be the same until the body is cooling. So, from the Newton's cooling law, we can predict how long it will take for a hot object to cool down at a certain temperature. So, in this question, we can know the time of death before the corpse is found. That's all from us. Thank you and have a nice day.